Cool. So let's decipher the graph model. I trust everyone has seen what I've done there. So I'm Don Davis, and I'm CTO and co-founder of a startup called Marionette, and we're building the next generation of configuration management databases. This is backed by neo4j because the assets in an enterprise don't live in silos of relational data. They're interconnected graphs. And graphs are everywhere. It's not just a catchy marketing slogan, it's also very true. But finding graphs is easy. Modeling them is the fun part. Most basic texts on graphs start with things like this: vertices with edges. And then they dive off into graph theory. That said, making the leap from the world of numbers and letters into something slightly more useful isn't that hard. And being a property graph with neo4j, we can embellish our data with some useful stuff, which is lovely. But jumping straight into the Cypher isn't necessarily the best way to go about discovering the model of your world. A graph is basically a way of modeling the world using interconnected triples. So these triples then use the noun, verb, noun type format. So graphs are everywhere, and speaker gives talk. It's just English. Now, the astute among you may notice that there are other languages out there, and some of them don't follow this particular format, but we can make this work for any language, like Japanese, or Arabic, or Proto-Austronesian, or whatever obscure language you happen to speak. You simply reason about your model in your natural language and then map it back to the subject, verb, object for your graph when you're done. So if you're going to model the world, let's start with the nouns of that world. If I was going to model this conference, we might start with a speaker, talk, delegate, and room. Taking our nouns, we can then form sentences with verbs. Speaker gives talk in room, and delegate attends talk in room. We're creating a model that we can reason about because it's using natural language, so we can just talk about it. Once we have our nouns and our verbs, we have labels and relationships. The graph model just falls out, nice and easily. And we can start embellishing our data. So speaker has a name. Has implies a property. Room also has a name, and talk has a title and a start time, but does it have an end time? Or does it have a duration? This really comes down to the question you're going to be asking of your model. So questions like, how long did I spend in talks? And how long did I spend giving talks? Are possibly better answered with a duration. It's an easier calculation. But a question like, will I be out of talk A in time for talk B? May be easier with an end time. Now, we could go and put company and role as properties of the speaker, but I have 3 roles at 3 different companies. Also, speaker has role at company looks very much like verbs and nouns to me. Not only that, but delegate has role at company too. So let's build these as part of the model, not tucked away inside properties. So we can then say a company has a name and a role has a title. And we have the basis of a model. And we've achieved this through language, and language that can be understood by anyone, which is really useful when you're modeling a graph in a domain that may actually be understood by people who don't know about Cypher and neo4j. So you can speak with these domain experts and build your model up using natural language. Now, there's some considerations once you take this model and convert it into the graph. While our verbs made sense with our nouns, we're now viewing the world as instances of those nouns. So speaker has role made a certain amount of sense. Don Davis has CTO doesn't sound good in English. So we want to make sure that the semantics of our model survive the translation into the graph world. And there's another potential issue that I've highlighted here. I've opted to have role as one-to-many relationship. So as a result, speaker to role must be one-to-one. And to understand why, we need to look at a slightly different data set. Person has role at company. Because director has many relationships in and many relationships out, with this particular model, it's impossible to tell who is the director of which company. we need to have an unambiguous route or path for us to follow. Now, that's not the only way we could model that data. If we just care about companies and company directors, then this might actually be a more sensible model. Data-wise, this and this are pretty much the same, although this is more flexible. Having hundreds of different relationships between roles is not a good design. And we can also store properties like start dates on the role. Now, we could do the same on the has-director relationship, but we can't really index those properties, and it's inefficient if we want to search on it. Relationship properties really are there to help you make a traversal decision, or to give you data once you've made that particular traversal. If you go to search on them, there's a sign that maybe you want to stick them in a node, which is fine. Although sticking extra nodes into the model seems to be a very alien concept to some people. But if you think about it, unless you have an atomic node and an atomic relationship with no properties, your graph can always be described with more nodes. So this can also be written as this. It's logically the same. Of course, this is making a rod for your own back. But let's consider the speaker has role path. For the conference profiles and the like, I needed to have a primary role, so they could put that on my bio. And we could tag this in our relationship with the has role. But wherever you see this particular construct, you can also replace it with a specific relationship type. Or record it as a new node, in this case, something coming off the role. The abundance of ways to describe things within the graph is why you really want to drive the model from the language of the domain, not from the cipher. If you consider the graph model that I'm working with, we have the idea of concepts and properties and relationships. Now, this sounds like it's a one-to-one mapping with nodes, properties, and relationships in the graph, but it's more complex than that. I have no idea how many properties a particular concept may have, and I have no idea what they're going to be called. So hopefully we can all agree that this setup is absolute madness. And while this is more extensible, I don't want to see the query plan for things like find me all the concepts with a name property. Instead, we looked at how we described the domain. Concepts have properties. So while has implies a property on a node, has many implies relationships and nodes. And the solution was this, which is effectively defining property nodes using property nodes and relationships, which is all very meta. And then below this, we have the idea of instances, which have values. So we're defining a schema on our graph and then storing data under that schema. And in fact, we actually have a schema node, which lets us do some really interesting stuff, because my model is a meta model, and the concepts define that it have an annoying habit of being called different things by different people, not least because of things like localization and different languages. So we can have the idea of aliases, and a concept has a primary name, which we give it, and then people can define aliases on that model. And then you can start asking questions of that model using the terms that you would naturally use. So if you're talking about a ticketing system, you can talk about Jira or you can talk about Bugzilla. And that ticketing system can have tickets, or it can have issues, or it can have tasks. You just add the aliases. So the building blocks that Neo4j gives you are really simple, but they're very flexible and powerful. And I've used them to model something that's quite basic, but which in itself lets you model something quite complex. So have I just reinvented the wheel? No, because when we came to model the domain, we were talking about terms of, we weren't talking about terms of ticketing systems and tickets and stuff. We were talking about arbitrary concepts with properties and relationships between them. These are the terms that we were using. These were my nouns as I was discussing the Just ignoring those are nouns because they look superficially similar to what's on the graph is not a good thing to do. We shouldn't ignore what the language of the domain is telling us. To write the model at this level, I mean, it can be done, but I would be adding new labels on a daily basis, and I would be having to change my queries and update things, and extending my library of queries every single time the model changes. Whereas this handles arbitrary changes in what we're describing. And amusingly enough, it also provides us with two models to describe and reason about, the meta model, which I've done, and the model that's written on top of it. The meta model is mostly complete and static, and the new model is evolving. And we reason about it using the same type of language. The same advice applies, because it really is just graphs all the way down. Thank you very much.